This is the second part of the 9.5 lesson. This is where we actually do the real math of adding and subtracting rational expressions using the division, adding. So what I'm going to do with this first one is I'm going to have to do the prime factorization. I'm going to show you that even though you realize it's very easy to do without prime factorization, you guys realize that all you have to do is multiply both the top and the bottom by 6, because 5 times 6 is 30. Okay, but I want to show you guys prime factorization just so that let me change over here, just so that you can see how it works. So 3 over 5, that's already factored. There's nothing we can do with that 5. So I'm going to rewrite it as 3 over 5 plus 7 over 30. Now the 30, if you divide it by 2, you're left with 15. If you divide 15 by 2, you don't get a whole number, so you have to then divide by 3. Remember, the prime numbers are 2, 3, 5, 7, 11, 13, and so forth. You probably won't have to use any numbers past that. So if 15 isn't divisible by 2, then you ask, is it divisible by 3? Why, yes it is. 5. Then is 5 a prime number? It sure is. So 30 being factored is 2 times 3 times 5. So instead of writing 7 over 30, I'm going to write 7 over 2 times 3 times 5. Now, what I'm going to say is, does the denominator of this fraction on the left have a number that this fraction doesn't have on the bottom? No, they both have a 5. Then you ask, okay, does this denominator have some numbers that this denominator doesn't? And you say, yeah, it does. It has 2 and 3. So what you're going to do is take that 2 and 3 and multiply it both by the top and by the bottom. So multiply both the top by 2 times 3 and the bottom by 2 times 3, so that you have denominators of 5 times 2 times 3 in both. Then you say, all right, top 3 times 2 times 3 is 18. Over 5 times 2 times 3, which is 30, plus 7 over 2 times 3 times 5, which is 30. What you get? 18 plus 7 is 25 over 30. You can divide both those numbers by 5. 25 divided by 5 is 5. 30 divided by 5 is 6. Now we're going to take that same principle of factoring and apply it to algebraic. Here we go. First thing I want to do is factor this first denominator. So I look at 1 over x squared plus 5x plus 4, and I'm going to rewrite that factored form. So 1 over x squared plus 5x plus 4. What we can see is that two numbers that added before, and multiplied before and added to 5 would be x1 and 4. Then I'm going to do the same thing with this denominator. So I'll still have 5x on top. I'm going to move it over just a little bit. But I can factor out a 3 out of this denominator, so it's 3 times x plus 1. Then I ask myself, alright, what does this denominator have on the left that this denominator doesn't? I say, well, it has an x plus 4. So what I do is multiply both the top and the bottom of this fraction by x plus 4. Then I ask myself, okay, from this original denominator of 3 times x plus 1, what does this denominator have that this denominator doesn't? Well, it has an x plus 1, but it doesn't have that 3. So I multiply both the top and the bottom by 3. And what you then see is that both of these bottoms have an x plus 1, an x plus 4, and a 3. Let's simplify this. 3 times 1 is 3 plus 5x times x plus 4 all over 3 times x plus 1 times x plus 4. I'm going to leave the bottom factor, but I'm going to simplify the top. And 5x times x is x squared, so I'll have 3, so plus 5x squared, and then 5x times 4 is 20x, all over 3 times x plus 1 times x plus 4. And what the book likes you to do is leave the bottom factored, but it wants you to put the top in standard form. So what you want to do is put the 5x squared first, then the 20x, then the positive 3, all over 3 times x plus 1 times x plus 4. Let's practice another one. Do the same thing with the first fraction. 1 on top. What I realized then is that I can factor out a 3, and I'm going to be left with x squared plus 7x plus 10. But x squared plus 7x plus 10 can be rewritten as x plus 5 times x plus 2. So I'm going to erase this, put x plus 5 times x plus 2. Then I have 4x over 3x plus 15. I can factor out a 3, and I'll be left with x plus 5. And that's all I can do. Now I go through the same steps of asking, what does this denominator have that this denominator doesn't? Well, they both have a 3, and they both have an x plus 5. So what this one is missing on the right is an x plus 2. What I'm going to do is multiply both the top and the bottom by x plus 2. And you ask yourself, okay, what does this denominator on the left have that this denominator on the right doesn't? Well, it doesn't have anything extra. They both have the same now. So I will start simplifying. Still have the 1 on top, plus the 4x times x plus 2, all over 3 times x plus 5 times x plus 2. Start simplifying. 1 plus 4x times x is 4x squared. 4x times 2 is positive 8x. Leave the bottom factored. And then put the top in standard form. 4x squared plus 8x plus 1 over 3 times x plus 5 times x plus 2. And that's it. Some more practice. One on top. Factor out the denominator of the left fraction, and you will get two numbers that multiply to be negative 12, add to be negative 4. Those two numbers are negative 6 and positive 2. 3x on top. What can we factor, or how can we factor the denominator of this expression? Factor out a 4. You're left with x plus 2. Now we ask ourselves, what does the denominator on the left have that the denominator on the right doesn't? Well, they both have an x plus 2, but the denominator on the right is missing an x minus 6. So you multiply both the top by x minus 6 and the bottom by x minus 6. Now you look at this original denominator of the right and ask, what did that have that the denominator on the left didn't? Well, it has a 4. So you multiply both the top and the bottom by 4. Start simplifying. 4 times 1 is 4, plus 3x times x minus 6. With the bottoms both having 4 times x plus 2 times x minus 6. Some of you guys might be asking, can't I factor out x minus 6 from the top and from the bottom, going like that? No, you can't, because x minus 6 is attached to the 3x, but that's being added to the 4. Okay, so it's really not a factor. You can only factor things out when they're all being multiplied on top and bottom. So we will simplify. 4 plus 3x times x is 3x squared. 3x times the negative 6 is negative 18x. All over 4 times x plus 2 times x minus 6. Rewrite the top in standard form. So you have 3x squared minus 18x plus 4 over 4 times x plus 2 times x minus 6. Keeping it going. Now, you guys should be getting the hang of this a little bit. Otherwise, if you are having problems, please help each other with this. This shouldn't be too bad, but please follow my steps to make it easier. And I will come back and I'll explain a little bit more, but don't be banking on this too much. On me spending too much, because you guys should be able to get this from the video. From here on, I'm going to go through these a little bit quicker. So, here we go. Factor out the bottom. So you have 7y on top. Factor out a 5. You're left with y squared minus 25. The y squared minus 25 is the sum of squares. So you could have, instead of y squared minus 25, you can have y plus 5, y minus 5. Four on top, factor out the 3 on the bottom, y plus 5. Start asking yourself, what does the bottom of the left have that the denominator of the right doesn't? Well, it has a 5. So multiply both the top and the bottom by 5. Does it have anything else that the bottom of the right doesn't? Yeah, it has a y minus 5. So multiply both the top and the bottom by y minus 5. What does the original denominator of the right have that the left doesn't? Well, they both have y plus 5, but the left doesn't have a 3 on the bottom, so multiply both the top and the bottom by 3. So we're going to take 7y times 3 is 21y minus 4 times 5 times y minus 5. 4 times 5 is 20 times y minus 5 all over 3 times 5 times y plus 5 times y minus 5. Start simplifying. You have 21y, and then minus 20 times y is minus 20y. Minus 20 times, or negative 20 times negative 5 is positive 100. All over 3 times 5, which is 15, times y plus 5 times y minus 5. Then go back and you see 21y minus 20y is just y plus 100 all over that denominator of 15 times y plus 5 times y minus 5. Keep going. X on top, factor out of 3, left with x squared minus 3x plus 2. You can factor that though into x minus 2 and x minus 1, so I'm going to do that. The bottom of the right you can factor out at 3, so you're going to be left with 3 times x squared plus x minus 2. And then you can factor that into x plus 2 and x minus 1. Now we start asking ourselves, what does the bottom of the left have that the bottom of the right doesn't? They both have a 3. They both have an x minus 1, but the bottom left has an x minus 2, whereas the bottom right doesn't. So you multiply both the bottom and the top by x minus 2. Then you say the original right bottom, or right denominator, what does that have that this left denominator doesn't? Has an x plus 2. So you multiply both the top and the bottom by x plus 2. So the whole denominator is 3 times x minus 2 times x minus 1 times x plus 2. The top, we have, let's go through this, x times x is x squared. X times 2 is 2x. Okay, we're taking all of this and then we're subtracting all of this. Now we have two binomials, we have to FOIL this out. 2x times x is 2x squared. 2x times negative 2, negative 4x. 1 times x is positive x. 1 times negative 2 is negative 2. This negative 4x plus x, I can think of that as negative 3x. And then an easier way is, or a quick way to get through this, is have this negative apply to each of these terms. So I can say that this is negative 2x squared. Negative would be positive. and a positive. So I can get rid of the parentheses and start combining like terms. X squared minus 2x squared is negative x squared. 2x plus 3x is 5x plus a negative plus another 2 at the end. All over the denominator of 3 times x minus 2 times x minus 1 times x plus 2. Okay, let's do another one. Write smaller hopefully this time. Negative 2 on top. Factor out a 3 on the bottom. You'll be left with x squared plus 12x plus 35. But x squared plus 12x minus plus 35 can be factored out into x plus 5 and x plus 7 minus 3x over 6x plus 30. Well, I can factor out the 6. I'll be left with x plus 5. And I believe that I might have made some mistakes earlier. Not that it mattered in the final answer, but I might have missed some prime factorization. And I see 3 is a number that's already a prime number. But 6, I need to factor this out. So I say, alright, 6 first divided by 2, and you're left with 3. Well, both of those are prime numbers. Instead of having 6, I'm going to have 2 times 3, excuse me. Then I start asking myself, what does the left denominator have that the right denominator doesn't? And it has an x plus 7. So I multiply both the top and the bottom by x plus 7. What does the the right denominator have that the left denominator doesn't? It has a 2. So multiply both the top and bottom by 2. Negative 2 times 2 is negative 4. Subtract all of this on the right. So 3x times x is 3x squared. 3x times 7 is positive 21x. All divided by 2 times 3 times x plus 5 times x plus 7. Now, just as I did before, I thought of this negative as applying to both terms on the inside of this parentheses. So I apply it, and this becomes a negative 3x squared and a negative 21x. And then we have that negative 4, which doesn't need the parentheses anymore. Rewrite this, take the 2 times 3 and simplify that, so I can have, in standard form, negative 3x squared minus 21x minus 4, all over 2 times 3 is 6, times x plus 5 times x plus 7. Going on, it gets a little bit more complicated. So I'm going to take this one part at a time. I'm going to look at just the top first, and then just the bottom. So 1 over x plus 3. Now what you can do is think of that as 1 over x plus 3 over 1. Both of those fractions are factored, because you can't do anything with either of these denominators. So you ask yourself, okay, what does the denominator on the left have that the denominator on the right doesn't? An x. So I can multiply both the top and the bottom by x. Then you say to yourself, okay, what does the denominator on the right have that the denominator doesn't on the left? Well, they both have a 1. You multiply anything by 1 as itself. So I'm going to simplify the top here. I'll have 1 plus 3 times x all over the denominator of 1 times x, which is x. Now I'm going to do the same thing with the bottom. Five over y plus 4 over 1. What does the denominator on the left have that the denominator on the right doesn't? It has a y, so multiply both the top and the bottom by y. What does the denominator on the right have that the denominator on the left doesn't? Well, it doesn't have anything missing. Suppose you could multiply by 1 on both top and bottom, but it really doesn't do anything. So 5 times 1 is 5, plus 4 times y is 4y, over y times 1 is y. From there, when you multiply or when you divide a fraction by a fraction, it's the same thing as dividing the top fraction by the reciprocal of the bottom. So what I'm going to do is rewrite this top fraction, 1 plus 3x over x, but being multiplied by the reciprocal of the bottom, which is y over 5 plus 4y. From there, if you want to simplify it out a little bit more, you can take the y, multiply it by both the 1 and by the 3x. And then do the same thing with the x. Multiply it by the 5 and by the 4y. And that would be your final answer. Same thing here. We're taking 1 and we're dividing it by x over y. When you divide by a fraction, it's the same thing as multiplying by the reciprocal. So we'll take 1 times the reciprocal of x over y is y over x. One times y over x is just y over x. And then we still have 3 on the top here. This is another one where we're taking a whole number divided by a fraction, or what's going to turn out to be a fraction. So we have a 3 on top divided by 1 minus 1 over 2y. Now this 1 over here, we can think of that as 1 over 1. Now what does this denominator have right here that this denominator doesn't? Well, a 1 doesn't really count, doesn't do anything. So you look at this one and you say, what does this denominator have that this denominator on the left doesn't? It has a 2y. So I'm going to multiply both the top and the bottom by 2y. Still have the 3 on top, but the bottom fraction is going to have a denominator of 2y. 1 times 2y is 2y minus 1. Then you say, alright, that 3 is going to be multiplied by the reciprocal of that fraction on the bottom. The reciprocal of the fraction is 2y over 2y minus 1. And when you take a whole number times a fraction, it multiplies to the top. So 3 times 2, 6y over 2y minus 1. And that's it. This is your homework. good luck.